Hello guys, and in this video I will be going over Unit 2, Lesson 2.11, the Bohr atom. So, I will not read all of this. I will just gradually skim through the main ideas, to save time. So, let's get ready. The model of the atom is changed over time. So, to look at this picture, we see that in 1913, Niels Bohr represents an atom, much like our solar system, with electrons orbiting the nucleus. Here are the electrons and their orbitals. And then here are the protons and neutrons in the nucleus. Quoting Niels Bohr, he said, "Perhaps I have found out a little about the structure of atoms." So, to look at his model, the Bohr model, which is what we just looked at in the previous page, I believe this was created in 1913. Niels Bohr represents an atom, much like our solar system, with electrons orbiting the nucleus, with the electrons in their orbitals, which we will be getting further into, and the protons within the nucleus, with the neutrons in the nucleus too. Bohr suggested that electrons are found in distinct paths around the nucleus. Okay, so the definition of Bohr's model is an atomic model that shows that electrons are found in discrete orbitals around the nucleus of an atom. And orbitals are an area surrounding the nucleus of an atom that contains one or more electrons. Here are some examples of Bohr models for specific atoms. So, how many elements?
1.
Boron. How many electrons does the atom have? Well, we can simply look at it and see there are 5. How many electrons are in the orbital closest to the nucleus? If we look, that would be 2. 2 electrons. How many electrons are in the next closest orbital? Well, that would be 3. Now, if we were to look at this last question, how does the energy of the electrons differ from the innermost orbital to the outermost orbital? Well, there are 2 orbitals. This one, which is closest to the nucleus, and this one, which is the farthest away. The one that's farthest away has more energy than the one closest, so that's the difference. So, phosphorus. How many electrons does this atom have? Simply, we can look at the number of protons in the nucleus, and we can tell that there are also 15 protons. Electrons, I mean. Don't mind this, I accidentally just hit something. How many electrons are in the orbital closest to the nucleus? We can look, there's 2. So, how many electrons are in the second closest orbital? There's 1, 2, 3, 4, 5, 6, 7, 8. I might have counted wrong, but I guess we'll see. How many electrons are in the third orbital from the nucleus? That would be 1, 2, 3, 4, 5. Okay, how many electrons does this atom have? Easy, that's 19. How many electrons are in the orbital closest to the nucleus? 2. How many electron orbitals are surrounding the nucleus? That would be 4, I believe. Because each ring is an individual orbital, and there looks like there's 4 of them. How many electrons are in the outermost orbital? That would be 1. Last one. Krypton. How many electrons does this atom have? 36. How many electrons are in the outermost orbital? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. How many electrons are in the third orbital from the nucleus? Which would be this one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. So we just completed that. Good job, guys. Okay. In Bohr's model, electrons had a certain set amount of energy. That is called an energy level. So, regarding electrons, stable state of energy and configuration of electrons as they orbit the nucleus of an atom, also shell. For an electron to move farther from the nucleus, it must absorb energy. So let's look at this. So a low energy photon strikes an atom. An electron absorbs the photon's energy and jumps to a higher orbital level. Here the electron jumped from orbital 1 to orbital 2. A high energy photon strikes an atom. The electron absorbs more energy from the high energy photon, and the electron jumps a few more levels. Each time a photon strikes the atom, the energy level in the electron increases. If the photons give the electron enough energy, the electron escapes the pole of the nucleus and the atom becomes ionized. Simple enough. For an electron to move closer to the nucleus, it must release energy. When an electron emits a photon, it loses energy and drops to a lower orbital. An electron continues to drop through lower orbitals as it loses photons. This is the lowest amount of energy an electron can have and still be in an orbital. The discrete jumps between energy levels are quantum changes. So, what does quantum mean? Quantum means a discrete amount of energy. So let's look at quantum changes. The electron orbits at one level until it gains enough energy to jump to another. So now it's in 2, 3, 4, 5, 6, 7. A valence electron is any electron located in the outermost orbital.
Valence.
Okay, valence electrons are electrons occupying an atom's outermost energy level, or electron shell, which determine an element's reactivity. So, looking at this, we see that there are 2 orbitals for oxygen. This one, which is the one closest to the nucleus, and then this one. This has valence electrons in it because this is the outermost. Excuse me. This is the outermost orbital. For aluminum, this would be the outermost. Same with calcium, and same with krypton. Okay, so Bohr's model will be very useful in your study of chemistry. Bohr's model of an atom with the placement of electrons in specific orbitals, also called energy levels or shells, outside the nucleus will be useful for most of your studies in this chemistry course. Each electron in an orbital has a specific amount of energy. Electrons can move from one orbital to another, and when they do so, they either gain or lose a discrete amount of energy known as a quantum. The electrons in the outermost orbital are called valence electrons, and they play a key role in the chemical interactions between atoms. Atomic models developed by Bohr introduced electron orbitals and energy levels. Atomic model, outer electrons named valence electrons. I hope dearly that this review lesson helped, and good luck.